All right, so 4.10, we're talking about applications in sinusoidal curve fitting. What do we mean by sinusoidal?
Multiple. Wait, no, it has two ends, or it means the same. I remember you said.
It means it's going to have that sine curve looking thing, but it doesn't mean it's just sine. It could also be cosine, okay? So it's just meaning it's got the shape of sine and cosine, so they call it sinusoidal. All right, so it says we've discussed several characteristics of trig functions written in standard form. Let's summarize them here using the sine function. Describe and explain the changes to the graph for each variable in the equation below. So example 1 says given the standard form of a sine function, y equals a times sine of bx minus c, notice the b's inside parentheses, right? Plus d, complete the summary in the table below. So which variable is going to give me amplitude? And how do I find the amplitude using A?
Absolute value.
Absolute value of it. So is amplitude ever negative? No. Now what do we mean by amplitude? It says explain the effect of this transformation on the parent function. What is the amplitude going to do? Is it horizontal or vertical?
Vertical.
Good. It's going to be, I'm going to write two different things here, so that's why I'm only using half the box. So it's going to be a vertical stretch, or it doesn't have to be a stretch. What could it be? Compression. But what is the definition of amplitude? Yeah, like it's the distance between what? The midline and, good, the top, the maximum, or the midline and the minimum, okay? So it is half of the height of the wave. So I'm going to write over here in parentheses the distance from the midline to, I'm just going to put the maximum, but remember it could also be the minimum because it's half of it, right? So how do we find the period? Which variable is going to help us do that? B. And how do we use B? 2 pi over B. And what do we mean by the period? What is that? How long it takes a graph to repeat itself. So it's the length of one full cycle of the curve, or the wave. Now the phase shift. And be careful because remember we looked at the equation written two different ways. We looked at it with B inside the parenthesis and we looked at it with B being common factored out at the front. This one has it inside the parenthesis. So how do we find the phase shift? C over B. He's on a roll today. There's the key. There you go. All right. And so what is the phase shift? Yeah. So it's a horizontal shift. Good. And what about the vertical shift?
It's D.
That's our D. And what is a vertical shift going to do? You can't use the definition in the explanation. Yeah, it's how I know, because you're thinking D is our vertical shift, but it's the shift of the graph up or down, right? Yes. And what's the big thing that we say? D also represents what?
Midline.
The midline. Okay, so it's the midline. And it shifts the graph up or down. All right, so which expression in the table would change if the function was tangent or cotangent?
The pi over b.
Yeah, the period, right? And what expression would then be used?
Pi over b.
Pi over b. Now, there's one other thing that would change too. Do you know what it is?
Let's see.
Amplitude. Because you told me that amplitude is from the midline to the maximum, correct? What's the maximum on tangent?
Infinity, right?
Infinity. So, can we have an amplitude if there is no maximum?
Infinity divided by.
You can't have amplitude if there's no maximum, okay? So, tangent and cotangents don't have amplitude.